In example 2D, we have another logarithm that we are going to try to expand into multiple logarithms, okay? So remember what the directions are going to read, okay? So if I scroll back up to the top, the directions for expanding logarithms are going to read, write each expression as a sum and or difference of logarithms, okay? Because you're taking one logarithm and turning it into multiple logarithms of the same base that you're either adding or subtracting together. Okay, and again, you're going to express powers as factors. Okay, and again, I will remind you at the end of this example what that means. Okay, so here we have the natural log of something very complicated. We're taking the logarithm of 5x cubed times the cubed root of 1 minus x divided by 4 times the quantity x plus 1 squared. Okay, all right, so to start with, okay, we've got to ask ourselves what is going on here. Overall, are you taking the logarithm of something times something, something divided by something, or is this the logarithm of something to a power? Okay, yes, there's a lot going on here, okay, but overall, what is going on? Okay, well, this is the logarithm of a fraction. Okay, so we are going to begin by applying rule number 3 here. Okay, so we are going to apply rule number 3 here. Oh, sorry, not rule number 3, rule number 2. Okay, so we're going to start. Here's where you take the logarithm of a fraction. Okay, division turns into subtraction. Okay, so we're going to start by applying this rule. Okay, and then as we go further into the problem, we'll probably have to use the other two rules. Okay, again, can't emphasize enough, these three properties are really the only things you can do to logarithms. Okay, all right, so let's go back to the problem. Since this is the logarithm of a fraction, we're going to break this up into the natural log of the top. Okay, so the natural log of 5x squared times the cubed root of 1 minus x minus the natural log of the bottom, which is 4 times x plus 1 squared. Okay, so it's the natural log of the top minus the natural log of the bottom. Okay, now we need to keep going. Okay, we're going to have to expand each of these logarithms themselves. Okay, so again, there's a lot going on here. I'm actually going to color code it. So when I break down this first logarithm, okay, I'm going to put that result in red. And then when I break down the second one, I'm going to put it in black, just so you can keep track of what's coming from where. Okay, let's focus on the first logarithm and totally break it down. And then we'll come back and work on the second logarithm. Okay. All right, so here we go. We're still expanding here. Okay, so we've got the natural log of 5 times x squared times the cubed root of 1 minus x. The first thing I'm going to do is rewrite the cubed root so that it's converted to a power. Okay, so this is going to be the natural log of 5 times x squared times, if you have the cubed root of something, that's the same thing as raising it to the 1/3 power. So this is going to be 1 minus x. Instead of taking the cubed root as it's written, we will raise it to the 1/3 power. Okay, so that's going to be my first step because it's easier to work with the power instead of the radical here. Now I've got to look at this and say, okay, overall, what am I doing? Is this the logarithm of something times something? Is this the logarithm of something divided by something? Or is this the logarithm of something to a power? Okay, again, there's more than one thing going on here, but overall, what is the picture here? Okay, well, it is the logarithm of something times something. Okay, actually, it's the logarithm of something times something times something. Okay, this is the natural log of 5 times x squared times the quantity 1 minus x raised to the 1/3 power. Okay, so it's actually the logarithm of something times something times something. Okay, so what we can do is use property 1. okay, if you have the logarithm of something times something, it turns into more than one logarithm and you're adding, okay? So again, multiplication turns into addition. So this is going to be the natural log of 5 plus the natural log of x squared plus the natural log of 1 minus x to the 1/3. So far that one red logarithm has turned into 3 different logarithms of the same base. They're all natural logs, and we've turned multiplication into addition. Okay? All right. The last thing we can do here is apply rule number 3, where we know if we have the logarithm of something to a power, we can bring that power down in front. And as far as the directions are concerned, that part that I have highlighted in yellow where it says to express powers as factors, that's what it's referring to. Okay, that if you have the logarithm of some base of something to a power, you can bring that power down in front. Okay, that's what that yellow part is referring to, that you can do that. Okay, all right, so let's go down here and see if we can bring any of the powers down. Okay, natural log of 5, there's nothing I can do to it. If you actually put that in your calculator, that's going to be some crazy decimal, so it's just easier to leave it as natural log of 5. That's just a number. Okay, but in the second piece, you have the natural log of something to a power, so you can bring the power down in front. Okay, so we can rewrite it as plus, bring the 2 down, 2 times the natural log of x. Okay, and then the last part that we're adding, the last logarithm that we're adding here, it also is the logarithm of something to a power. Okay, so we can bring the power down in front. Okay, so this is going to be plus 1/3 times the natural log of 1 minus x. Okay, this is as far as we can go on this side with the red stuff. Okay, you might be tempted to distribute here, natural log of 1 minus natural log of x. You can't do that. Okay, I've given you the speech already. If you flip back to page 1, I wrote and circled in a big orange cloud, you cannot distribute through logarithms. Okay, so this is as far as we can go. Okay, so we've handled the first logarithm, but now we need to come back and deal with the stuff in black. Okay, so let's do that. Now we're going to be subtracting the result of breaking up the natural log of 4 times x plus 1, that quantity squared. Okay, so again, you've got to ask yourself, which situation does this fit? Does it fit multiplication, division, or the power? Okay, so am I taking the logarithm of something times something, or of something divided by something, or of something to the power? Okay, so when you look at this, okay, you should see that we are subtracting the natural log of something, which is the 4, times something else, which is x plus 1 squared. Okay, we have the logarithm of something times something. Okay, multiplication will turn into division. Okay, so here's where you have to be careful. Okay, we are subtracting this logarithm, and so when we expand it, it's going to turn into multiple logarithms. Okay, so when we subtract, we're going to have to put parentheses or brackets here. Okay, because when we break up this black logarithm, it's going to expand into multiple logarithms, and you're going to have to be careful because in the next step, if you see where my cursor is, we're going to have to distribute that minus sign. Okay, so you're going to have to be uber careful there. Okay, all right, so let's focus on breaking up this logarithm. Okay, this is going to be the natural log of something times something. Okay, so this is going to turn into addition. Okay, multiplication turns into addition. So this minus sign is staying right here. Okay, so in the brackets, I'm writing down how this logarithm expands. It's going to be the natural log of 4 plus the natural log of x plus 1 squared. Okay, that is how that one breaks up. Okay, it expands into 2 logarithms that we're adding together. Okay, it is the logarithm of the first thing plus the logarithm of the second thing. Okay, all right, so now what we can do is I'm going to bring down my yellow minus sign, okay? If I examine what's in brackets here, inside the black brackets, okay, I can't do anything to the natural log of 4. It is just a number. You pop it in your calculator, you're going to get a crazy decimal. Just leave it as the natural log of 4, okay? But when I look at the second logarithm here, I've got the logarithm of something to a power. So this power can come down in front. Okay, so this is going to be plus 2 times the natural log of x plus 1. Okay, again, you cannot distribute the logarithm here, so you're going to have to leave it like it is. Okay, all right, in the final step, okay, remember this stuff in brackets, we are subtracting. So you need to distribute the negative sign here and here. Okay, so it's going to be minus the natural log of 4. Okay, and then again, negative times positive will give you minus 2 times the natural log of x plus 1. Okay, this bottom line is your final answer, the stuff in red and the stuff in black. Okay, so I'll write down the overall answer in blue here. It's all the stuff at the bottom. It's the natural log of 5 plus 2 times the natural log of x plus 1/3 times the natural log of 1 minus x minus the natural log of 4 minus 2 times the natural log of x plus 1. Okay, so we started with one single logarithm. Okay, it has expanded into 1, 2, 3, 4, 5 different logarithms that we're adding and subtracting. Okay, so my advice to you, because you can see this is a bit tedious, okay, you need to remember the 3 major rules of logarithms. Those are the only things you're allowed to do to logarithms for the most part. Okay, you need to take it one step at a time. If you try to do this all at once, guaranteed you will make a mistake. Okay, be slow, go one step at a time, apply one rule at a time. Okay, that is my best advice to you.